So we have this nice correlation here between temperature, inferred by the hydrogen to deuterium ratio, and carbon dioxide concentration, and all this data is from the ice cores. All right, so now obviously there's great fluctuation, and back in this, 160,000 years ago, there was not industrialized civilizations. All right, there was, primitive people perhaps, but there was not a lot of, we think, carbon dioxide being produced from humans. Okay, so so you can see, though, there is some natural fluctuation in carbon dioxide concentration. See, there's other factors, though, that can also contribute to increased temperature. Carbon dioxide is not the only greenhouse gas. The other two most important greenhouse gases are water and methane. But the reason why we aren't showing a lot of data with water and methane right now is because water is very, very difficult to control, the concentrations of water, and we definitely cannot correlate human activities directly to water concentrations like we can carbon dioxide. And methane also is given off by plants, and it leaks from the fissures in the ground and whatnot. So that's sort of hard to track. Also, it's clear ice ages from the data. Ice ages have come and gone over time. And this is also, it can be attributed to slight changes in the Earth's orbit. The slight tilt of the Earth can change the intensity of the radiation that comes. And it has been shown that the orbit does change slightly over time. All right, but the slight changes in the orbit of the Earth and the kind of the angle at which the Earth is to the sun can't really explain the change in the global temperature. All right, so looking at some more recent data, this is the change of carbon dioxide versus time again. This time we're not going back we're not looking at ice core data, we're not going back 160,000 years. This is recent history. This is just from 2000 back to 1860. All right, we can get some ice core data up to this point in time, from the most recent ice core data. This is the very end of the ice core data that was shown on the previous slide. But it was around this time, in the 50s and the 60s, that people started really recognizing that humans could possibly affect climate based on their activities. And so at this point in time, late 1958, is when some very, very good data started being collected. So this is just from ice core. This is when scientists started paying attention. So this is called the Mauna Loa data. This was from a carbon dioxide collecting station in Hawaii, and this is just from ice cores. Okay, and so what you see is that this is the atmospheric carbon dioxide concentration in parts per million, and this is time. And you can see that since the 1958, you can just see the dramatic increase over time in the concentration of carbon dioxide. Now, why is that from about 1958? Why is it going up so fast? Well, the Western world was well into the Industrial Revolution and burning a lot of fossil fuels. But then the other countries that were not quite where we were, such as China, Russia, India, all those countries with lots and lots of people started burning more fossil fuels as well. Now, remember, if you burn a fossil fuel, like, for example, in your car, what is the product? The product is carbon dioxide. Okay, so as we continue to pull more and more fossil fuels and coal, which is also considered a fossil fuel, gasoline and coal, and natural gas, they're all carbon-based compounds, hydrocarbons. What we're doing is we're producing more and more of the product, which is carbon dioxide. All right, so we have this data, and then we also have better average global temperature data over that time, where we can actually, people have been keeping records of the temperatures using modern equipment, and you can see that the average global temperature has also started to climb, sort of at around 1958. You can see this direct increase as well. So I plotted both of these. Let me see if we can see them both. Whoops, let's see here. Plotted both of these graphs on one page. So you could see this is 1880 to 2000, this is 1860 to 2000, so the axis is slightly different. This is the temperature, and again, this is the 0 would be compared to the average temperature, and this is below average, and this is above average. 0 is where the average, and this is 0.6 degrees Celsius below and 0.8 degrees Celsius above. And this is the atmospheric carbon dioxide concentration in parts per million. And you can see this direct correlation between the average global temperature increasing and the average concentration due to seasonal fluctuations from the data. So the question then is, we need to really understand better, what is it about carbon dioxide that traps heat? We see that there's definitely the data, there's a lot of other factors, other greenhouse gases. So we want to understand, really what is it about the carbon dioxide that causes it to trap infrared radiation, whereas nitrogen and oxygen don't so much. So we have to understand molecular shape to truly understand what's going on here.